Hi everybody, today is Module 2, Lesson 4, Efficiently Adding Integers and Other Rational Numbers. Students will be able to use the rules to add integers. So some of you have been feeling ready to get rid of the number lines. If you still need the number line, you may use it after today. But we are going to talk about what the rule is and make sure that you are starting to learn how to do it without the number line. But again, you are always welcome to use the number line. So we've been talking about integers, the positive whole numbers, the negative whole numbers, and zero. The title of this lesson talks about integers and rational numbers. So remember I said the decimal, positive and negative decimals, and the positive and negative fractions are not integers? They actually fall into the category of rational numbers. So a rational number is any number that can be written as a fraction or decimal. They are positive and negative. So rational numbers are the positive and negative whole numbers, positive and negative fractions, positive and negative decimals, and zero. So I would like you to start the Eureka packet. Pause the video and try this page. Don't turn to the next page, just stop at the bottom of this page. So represent the sum, 3 plus 5, so 1, why isn't it working? 1, 2, 3, arrowhead, 1, 2, 3, 4, 5. And for years we've known the answer to 3 plus 5 is 8. How long is the arrow that represents 3? 3 units to the right. How long is the arrow that represents 5? 5 units to the right. What is the sum? The sum is 8. If you were to represent the sum using an arrow, how long would the arrow be? And in what direction? If I had just gone directly to the sum, it would have been 8 units to the right. So what is the relationship between the arrow representing the number on the number line and the absolute value? The arrow and the absolute value are the same. The absolute value of 8 is 8 units. The arrow for the sum is 8 units. Do you think that adding two positive numbers will always give you a greater positive number? Why? Yeah, I think it will. Not only because we've been doing it for years, right? You guys have been adding positive plus a positive since kindergarten, first grade. But on a number line, if you're moving to the right with the first addend, moving to the right with the second addend, you're moving further into the positives. You're moving deeper into the positives. You're moving deeper into the positives. All right, so pause the video and try all of B. This brings you to the next page. So negative 3, 1, 2, 3, negative 5, 1, 2, 3, 4, 5, and I land at negative 8. How long is the arrow that represents negative 3? It's 3 units to the left. How long is the arrow that represents negative 5? 5 units to the left. What is the sum of negative 3 plus negative 5? Well, the final stop was negative 8. If you were to represent the sum, negative 8, using an arrow, how long would the arrow be? It would be in what direction? It would be 8 units to the left. Do you think that adding two negatives will always give you a smaller negative number? Why? Remember, not smaller as in absolute value smaller, but the deeper you go into negatives, the smaller the value. So, yes, I do think negative plus a negative will always give me a smaller negative. because I'm going deeper into the negatives. Think about that number line. You're continuing to move further to the left. So what do both examples that we just did have in common? They're adding same signs. They added a positive and a positive, which gave us a positive. They added a negative to a negative, and we got a negative. So the rule, adding rational numbers. So remember, what we're doing with whole numbers still holds true for the fractions and decimals of positives and negatives. Adding rational numbers with the same sign by adding the absolute values and using the common sign. Really, just add them and keep the sign if you're starting with the same sign. If you're, I'll say it again. If you start adding 2 numbers or 3 numbers or 4 numbers, but if they are all the same sign, add it up and use the sign that they are. So why don't you pause the video and try all of A. Notice the directions without actually calculating the sum. All we want you to do is decide if your sum will be positive or negative, but do not actually calculate it. All right, a negative plus a negative is negative. A positive plus a positive is positive. A negative plus a negative is negative. A negative plus a negative is negative. A positive plus a positive plus a positive is positive. Negative plus a negative is negative. Remember, you're just moving 4 to the left and then another 2 to the left. So you're moving deeper into the negatives. 5 to the right, another 9 to the right. So you're moving deeper into the positives. Adding same signs. You just add the 2 absolute values and keep the sign. Why don't you pause the video and try all of B. If you really need a number line, go ahead, but some of these numbers get larger. I hope you didn't use a calculator. I hope you actually did it. 15 plus 7 is 22. They are both positive, so my answer is positive. Negative 4 plus negative 16. So in my head, I'm thinking, or on paper, I'm thinking 4 plus 16 is 20. They're both negative, so I keep the negative. Negative 18 plus negative 64. They're both negative, so I know my sum is negative. 64 plus 18, so negative 82. Negative 205 plus negative 123. They're both negative, so I know my sum is negative. 205 plus 123, because I'm going to move to the left 205, then I'm going to move 123 more to the left. So I'm landing at negative 328. Now I'd like you to pause the video and try all of A. This goes into the next page. No? I guess it ends on this page. I don't want, where do I want you to stop? I want you to stop. I want you to do all of A, which goes into the next page. So 5 plus negative 3. 1, 2, 3, 4, 5. Remember, I hope you're putting your arrowheads on, because now the direction reverses. It changes. 1, 2, 3. And I land at 2. How long is the arrow that represents 5? 5 units to the right. How long is the arrow that represents -3? 3 units to the left. Which arrow is longer? The positive arrow was longer. And what was the sum? The sum was +2. If we were to represent the sum using an arrow, how long would that arrow be? And in what direction would it point? It would be 2 to the right. Let me show you what I'm talking about. The sum, here we go. That landed us at 2. I'm going to leave the dual screen up for a moment. How about B? 4 plus -7. So I'm going to go to the right 4. 1, 2, 3, 4. Then I'm going to go to the left 7. 1, 2, 3, 4, 5, 6, 7. And I landed at -3. In the two examples above, what is the relationship between the length of the arrow representing the sum and the length of the arrows representing the two addends? Well, let's look at the length of the arrow of the sum of 4 plus -7. I guess we should start there. The sum was right there. Doesn't like the arrowhead. There we go. So I guess what I want you to recognize is that the non-overlapping represents the sum. See how the blues, there's some space here where I put the pink, where it's not overlapping? And on the other example, the 5 plus -3, the blues are overlapping, but where they're not, the non-overlapping is the pink, and that represents the sum. So the takeaway here, the sum is positive if longer arrow is positive. It may not be the first one, it may not be the second one. Okay, there's no rhyme or reason to that. But the longer arrow in the first problem on the left of the screen, the longer arrow was positive, and our answer is positive. On the example on this screen, the longer arrow was negative, and the answer is negative. So the sum is negative if longer arrow is negative. So what will our rule be? Our rule, subtract the two addends if you're working with opposite signs. That's the big thing. If you're working with opposite signs, subtract the two addends and then use the sign of the longer arrow, or what would be the longer arrow. So please pause the video and try all of A. How did you do? Sometimes the longer arrow, or greater absolute value, is the first addend. Sometimes the longer arrow, greater absolute value, is the second addend. Whichever is the longer arrow, which would then be the greater absolute value, that is the sign of your answer. Why don't you try these problems? So sometimes it's the first addend that goes on top, sometimes it's the second addend that goes on top, right, when you're subtracting. The greater absolute value is the number that goes on top when you're subtracting, and the greater absolute value is the owner of the sign for the sum. So this is where we are going to stop for now. Feel free to rewind, play again. There was a lot in today's video. And you'll be able to ask any questions you need the next time we meet. So I'll see you then. Bye.